In this video, we're going to talk about radian measure. Radian is a form in which we define a measurement, very much like that of degrees. Now, the question that I have is, where does the degree measure come from? It seems arbitrary and random when we talk about a full circle. Again, when we create a full circled angle, there are 360 degrees in that circle. Now, the question is where does that come from, and why do we say 360 degrees? That seems to be really arbitrary. Well, back in the day, we didn't use we didn't have 360 as an arbitrary number. It came from the concept of how many days it takes to rotate around the sun. So this knowledge was approximately 360 back, I believe, in the Egyptian days, of how we defined the number of degrees in a full rotation, specifically based on, again, the number of days it takes for the Earth to revolve around the sun. Well, this is still kind of arbitrary. Why didn't we use 1,000 or 10 or 100? Degree seems like a very arbitrary number based on what the world works in terms of. So what we're going to do instead is we're going to go ahead and define a new measurement called radian measure, which focuses on the concept of a radius. So if I take a circle and I have its radius measure, r, the radian, a single radian, focuses on the number of times it takes for us to take this radius. This is, again, arguably in standard position. Take this radius, bend it, and rotate it up through the angle, like this. So that right there would have an angle measure, and I'm going to use theta for each measure of angle, is going to be 1 radian measure. Okay, so now this is arbitrary based on the circle we're playing with. So for every single circle, no matter how big or small, this same distance is going to be this radius measure. Now the question then comes around with, well, where does that pi come from? That pi actually comes from the concept of the number of radian measures it takes to circumvent half of the circle. So if I were to take this and I go ahead and do another one right about there, there's my second radius, again, bent around the circle. I'm going to bend one more. There's your 3 radius measures bent around the circle. I'm going to go ahead and do some more right there. This is 1, 2, 3, and some change. Well, pi is 3.1415 ... continues on forever, never stops, never repeats. That's what this amount is. There's 1, 2, 3 radians and 0.1415 ... so on and so forth, of a radian to finish the half circle. So that means that if I had 180 degrees, 180 degrees is equivalent to 1 pi radian. Now, in most cases, when I write radian units, I'm not going to actually write the word radian, because every time I write a number and reference an angle measure, if I leave out the unit, I'm referring to a radian. If I don't leave out the unit, then I have to put a degree measure. That degree measure will help me identify that it's in degrees versus it being in radians. So in this case, if I want to go ahead and do one full rotation all the way around, we would talk about 360 degrees. Well, keep in mind that if this is 1 pi and I repeat all of this cutting process, I'm going to again see if I can do this right. 1, 2, 3, and then that change again. Notice how it's 1 pi and then 2 pi. So 360 degrees is actually equal to 2 pi. And again, I'm going to leave off the word, but the word is radians. That's how many radians it takes to circumvent that circle. That's the angle measure we're talking about. So that right there is 1 radian measure. That right there is 2 radian measures. That right there would be from here to here all the way 3 radian measures, and so on and so forth. So what we're going to do next is we're going to go ahead and talk about how to convert between radians and degrees. It's not terribly difficult, but it does take some getting used to. The first and foremost detail is this one right here. That's what's most important when trying to convert between radians and degrees. So if I start off with, let's just say I have 45 degrees. How am I going to convert 45 degrees to be in terms of a radian measurement? Well, if I know that there is a ratio or a comparison between radians and degrees, I know that ratio will be compared in this form. I'm going to put a box around it before I even write it. It's for every radian, there is a certain number of degrees, and I know that for the basic concept, there are pi radians to every 180 degrees. So if I'm given a degree measure, I can plug that degree measure in here and solve for r. If, however, a different example, let's say I'm given my radian measure theta equals to pi over, let's do 6 for this particular case. If my degree measure, if my radian measure is pi over 6, then I'm going to plug that in for r and solve for d. Now, there's another form of this particular formula or comparison, and that other comparison can be written in a number of different ways. For instance, I could do it this way. I could say that the number of degrees over top of 180 has to be comparable to that of the radian measure over pi. This is probably the better, safer formula to use. The reason why I write this one is because it's the one that makes the most sense in setting it up. But now this one, I can solve this equation if I multiply both sides by d, divide both sides by pi, and then that's going to give me this formula right here. Then I can plug things in relatively efficiently and just solve for the missing piece. So I'm going to use this formula here to solve for what radian measure is 45 degrees. So I'm going to have the degrees over 180 degrees has to be equal to, 45 degrees over 180 degrees has to be equal to radians over pi. So when I go to solve this, notice that 45 degrees divided by 180 degrees, the degree symbols will logically cancel out, just like if I had, say, centimeters divided by centimeters. Then I have 45 over 180, and 45 divided by 180 is actually 1/4. And then I'm going to multiply by pi to move it over to the other side. So I have 1/4 equals to r over pi, and if I multiply both sides by pi, r is going to be equal to 1/4 times pi, or, as most mathematicians work with, pi over 4. So this is one of the more prominent values we're going to have to remember, is that 45 degrees is the same thing as pi over 4 radians. And again, remember, if you leave out that degree symbol, you're not using degrees. So you have to make sure that every time that you go to write a degree symbol, an angle measure, if it's in degrees, you have to use that symbol. If it's in radians, you don't have to write the unit for radian. Okay? So what about pi over 6? Well, again, I'm going to use this formula right here. I'm going to plug the pi over 6 in for my radian measure, and I'm going to solve for d. So in this case, I'm going to have d divided by 180 degrees is equal to pi divided by 6, all divided by pi. Now, if we're real careful with this side, and that's what I'm going to focus on right now, is that side ends up being pi over 6 divided by pi. If I write it in this form, I can utilize that concept of keep, flip, change in my mathematics, and when dividing two fractions. Again, I'll change this into a pi over 1. So I have keep the first fraction, flip the second fraction, and change the sign of multiplication. Well, now the pi's in this case will cancel out. That should happen almost at all times. When working with radian measures, you'll find that if you're solving for a degree, the pi symbols, which is not a unit, it's not a unit, but it is a value, will cancel out. So that means that this side right here is really just 1/6. And therefore, if I have d over 180 equals to 1/6, I'm going to multiply both sides by 180 degrees equals to d. Now, when working with the math, you can go ahead and leave out the unit, but don't forget to put the unit back in at the very end. So in this case, if I go ahead and take 180 degrees divided by 6, I'm going to get d is equal to 30 degrees. So another important unit of measurement is 30 degrees that we use commonly, which is simply pi over 6. If you were to do this for one more important measurement, that important measurement is pi over 3, and pi over 3 is simply 60 degrees. So you have 30, 45, and 60. These ones you really should be memorizing. You have 180 and 360. You should really be memorizing these. And then we'll be talking about how we can memorize the rules for all the other multiples of pi over 6, pi over 4, and pi over 3. So anytime that we're trying to convert these things, the goal is to use, again, this formula right here. I will do one more example just to show that these are not the only ones we can do it with. We can do it with all sorts of types of examples. So again, I'm going to have d over 180 degrees is equal to r over pi, and then I'm going to go ahead and look at trying to convert, say, the degree measure of negative 300 degrees. So again, the fact that it's negative doesn't change the process. It's important to understand that we can plug in any angle measure for the degrees, or we can plug in any radian measure for r and still get back a value. So in this case, I'm going to go ahead and plug in the negative 300 over the 180 equals to r over pi. And then I'm going to go ahead and simplify this to the best of my ability. I'm going to multiply by pi. I'm going to get r equals to negative 300. I'm going to cancel out this and this right now because I can, over 18 times pi. And then I just have to simplify the 30 divided by 18. Well, I know 6 can go into 35 times, and I know 6 can go into 18 3 times, so I'm going to get negative 5 over 3 pi. Now, the reason why this one is so important for us to talk about is because 300 is actually a multiple of 6. So the way that I want to write this, the way that most of the cases I'll write that is this way. The way that I kind of want you to see it is negative 5 pi over 3's. Because what we're going to start doing is we're going to start talking about how radian measures can be more efficiently utilized in the what we're going to call unit circle. So in this case, I have negative 5 of these pi over 3's. Now, if we remember that pi over 3 is nothing more than a 60-degree measure, I can replace the pi over 3 with 60 degrees and notice that negative 5 times 60 is really just that negative 300 that we started with. So converting it back and forth, if we have the basic ones memorized, again, the 30, 45, 60, we should actually have 90 in there as well. I meant to put that one in there as pi over 2. 180 is pi and 360 is 2 pi. If we memorize all these rules, then transitioning from radians to degrees to help us better understand how to work with radians will give us a better functionality. So again, memorizing these main conversions is probably the most important detail that you can take away from this, and memorizing this rule in case we don't have a multiple of one of those particular situations.